Hey everybody, it's Spencer Blackman here from the Clinical Learning Team. And it's Friday. I thought, why not make another video? Actually, we've been seeing a lot of questions coming through around antibody testing. It's been a couple weeks since antibody testing arrived, which is ages in COVID time. So there was a couple questions I thought maybe we could dive into again and get a little deeper so we can kind of help clear up some questions that we have and questions that our patients have around the stage that we're in currently with antibody testing. I want to talk about how reliable is an antibody test result. And as you know, we're only ordering IgG. And when to order a PCR plus antibody test together. You probably saw the announcement today that we are starting to roll out combined testing in lots of our sites. And so when do we do this? So I want to talk about those kinds of things. Now, to talk about the first question, how reliable is a test result? I am going to do everything I can to avoid math, but there's going to be numbers in here. And I just have to say, I think that kind of going under the hood with how our tests work and understanding them, I think is really important. I think this is stuff that comes up in other parts of medicine. I think about screening tests that we do and other diagnostic tests that we do, and no test is perfect, and so understanding kind of what the limitations are and how to talk about those limitations and help patients make decisions is really valuable. So the first way to think about how a reliable test result is to ask how close to perfect is the test performance. If we had a perfect test, we would have 100% reliability of every test result. Now, because we don't have typically perfect tests, we don't have that. So we're going to look at how close to perfect, and then how common or rare is the condition in a community or population. And another sort of related question is just what's the pre-test probability? How likely is this condition in this person here? So let's dive into how close to perfect is the test. And this is where we're going to get into sensitivity and specificity. So one way that I like to think about sensitivity is how good is the test at identifying everyone who has the condition, right? If I'm going to test a population, a high sensitivity test, I will feel confident that I have not missed anybody that has the condition. So we're going to look at a sample population. Here, the light blue dots are people who don't have the condition, and the dark blue dots are people who do. So let's think about sensitivity here. So here is a test that has captured as a positive result everybody who has the condition. There's nobody who's a dark blue circle who has the condition that didn't get found by this test. And so this test has 100% sensitivity. It's a great test. It can capture everybody. We're not going to leave anybody out. In reality, sometimes tests will also call some people who don't have it positive. These are our false positives. And tests that have some false positives maybe don't have 100% specificity. But this test, even looking at it here, even though it has some erroneous results, still has 100% sensitivity. Then, of course, we want to ask about specificity. So how good is the test at identifying everyone who doesn't have the condition? And so now we're looking more at the light blue people who don't have it. So we're seeing way more test results that are negative. And again, here's a test that has 100% specificity because it hasn't missed anybody who doesn't have the condition. It is identifying correctly everybody who doesn't have the condition. Now, again, similarly, it might label some people who do have the condition as negative. These are false negatives. And that would, again, be lower sensitivity. It hasn't really identified everybody who has the condition. But even in this situation, we're looking at a test here that has 100% specificity. Okay, so we'll get back into sort of how that applies to our patient question, sort of the test result and how we use it clinically. But there's nothing wrong with going back and just going through all of that again to just like let it sink in and kind of wrap your mind around it. It's not super intuitive, and that's why it can be challenging. And I think thinking about it in different ways is the best way to start to get a real good handle on it. So let's look at how common or rare the condition is in the community or population. This is a term that you'll hear sometimes called prevalence, also known as pretest probability. And so here's an example where nobody has the condition. Zero prevalence. The pretest probability is 0. And so as you can see, we can now, if we knew that, we would know that every negative test is correct and every positive test is wrong. So this is showing you that when you have a very low prevalence, in this case 0, negative tests are more reliable than positive tests. And again, don't take that literally. Very good tests, they're all going to be mostly reliable, and we're going to see that. But the concept here is just when you have a very low prevalence situation, the negative tests get more and more reliable, and the positive tests get potentially less and less reliable. Now here's the inverse. So we've got all positive people, and most of the tests are correct, but there's a few tests that labeled people who had it as negative, so some false negatives here. Lots and lots of true positives. So in a very high prevalence situation, the positive tests are more likely to be correct than the negative. And again, understand that if you had a test with very high sensitivity and specificity, you wouldn't really have very many errors. And so you can probably rely on both. And again, we're going to look at that. But just in this situation, it's highlighting that in an extreme case where everybody has the condition, you know that your positives are always correct and your negatives are always wrong. We don't have anything like this, but it's kind of showing you that in a high prevalence situation, the positive tests are going to be really reliable, and it's possible that the negative ones will be more affected in their reliability. Okay, so let's put it all together. So when you combine those three concepts, sensitivity, specificity, and prevalence, you get our reliability values, and you probably heard these. The first one is called positive predictive value. So this is where if you have somebody with a positive test, what is the chance that that test is a true positive? Another way to say it is if you had 100 positive results, how many of those would be true positives and how many would be false positives? Negative predictive value, same thing. If you have somebody who has a negative result, how likely is that result to be accurate? Or if you had 100 results, what percent or how many out of those 100 would be correctly negative and how many would be false negative? So this is where positive predictive value and negative predictive value come from. And hopefully this is explaining why you have to have both sensitivity, specificity, and prevalence. You can have a very high sensitivity and high specificity test, but remember, if you have 0 prevalence, then all your positives are going to be false. So you have to combine them to really understand what the actual likelihood is of a test result being reliable. So now let's look at some examples. We're going to go even more real life here. So you guys are maybe hearing patients saying, hey, which tests can I get? Am I getting the Abbott test or the Roche test? It's amazing that patients are getting so into this, but there's a good reason. I mean, we're hearing that some of these tests have better sensitivity and specificity than others. I list these 3 tests because as far as we can get information from LabCorp and Quest, these are the tests that are most commonly being run. There's other ones, there's Euroimmune and IDK. Again, this is hard information to get real reliable information from the labs. We've talked with our reps, but my best understanding is that these are going to be more and more the ones we're going to be seeing, and the Euroimmune and the IDK are going to be phased out. And these 3 are especially good, especially the Abbott and the Roche. They're actually getting close to 99.9% specificity. So just to show you some data, this is a few weeks old, but this was data that LabCorp presented in one of their webinars. And I'm just showing you here that at that time, the Abbott test had a sensitivity of 100% and specificity of 99.6%. There's been actually more data recently that has reported a 99.9% specificity for the Abbott test. Here's the data that Roche is sharing. They're saying that they have a specificity of greater than 99.8% and a sensitivity of 100. And the diasorin is probably the least high-performing test, and it still has a specificity of 99.3%. So these are good tests. These are the tests that we are sending out to these large national labs. These are not those lateral flow cartridge point of care tests. There are going to be good versions of those. We're not using those yet. We're still trying to source those. And it is true that there are some worse and better versions, but the tests that our labs are doing are really good tests. So now let's talk about some real life situations. So let's look at New York. What I'm trying to show here is that New York, there's a decent number of people that have it, maybe 20% is what some of the numbers are. And with these good tests, you'll see that every negative result is correct. So when there's a negative result, it is always somebody who doesn't have it. When there's a positive result, they're almost all correct, but there's one in that middle there that you can see that's a false positive. Here we can say, in New York, higher prevalence, all the negative tests, basically 100% we can believe. All the positive tests, pretty darn good. Maybe there's a smaller chance for a false positive. And we'll look at numbers. we're going to use the diasorin numbers right now because I want to kind of use the worst numbers, and you can see how good it is. And then you can imagine as we get to the 99.9 specificity, we're going to see even better. So here in New York, if you have a prevalence of 20%, a positive result is 94.9% likely to be accurate, very high, and a negative result, 99.8. So you can rely in a higher prevalence place, you can rely on this test. If you're getting an antibody test, if it's positive or negative, in most cases, it is correct. So that is really reassuring to me. Let's look at San Francisco. So in San Francisco, for reasons that aren't totally known, the prevalence is much, much lower. It's thought to be maybe 1%, which is amazing for such a densely populated place. So here, again, what I'm showing is you're going to have fewer positives. Now you still have one false positive, but because you have fewer total positives, the proportion of the false positives is a bit higher. Let's look at the numbers. So if you think about the diasorin test, again, 1% prevalence, sensitivity, specificity 99.3. The positive predicted value is 59.2. So that isn't as good. That may or may not be something valuable for a patient. But even with a positive predictive value that isn't as great here, I still think that for some patients, they may feel there is value in even getting a 60% likelihood of their positive being accurate. The other thing to keep in mind is because the prevalence is so low, a negative test is 100% accurate. You cannot have a false negative. And again, I never really speak in absolutes, so sure, there could be exceptions, but think about it as you can trust a negative result. And so for some people, it might actually be that a negative result, and knowing that that's accurate, that they haven't had an immune response to coronavirus, they may change their behavior. So somebody who had symptoms and feels like they had it, there's a lot of people out there like that. And if they find out that actually they don't have antibodies to it, whether or not they had it, they probably didn't. But if they don't have antibodies, that may make them feel more vulnerable and take actions that are going to be more protective than they would have otherwise. And that actually might be even more important to think about than the people who are positive and maybe falsely positive and then have a little bit more bravado. I think there's both sides of that coin, and I think the test can be valuable and potentially increase safety in both scenarios. So now let's look at the Abbott and Roche test. So same number, San Francisco 1%, but now sensitivity and specificity is 99%. Hang in with me, I know it's a lot of numbers. The positive predictive value, same prevalence, goes up to 90%, and that's just because of the specificity getting so much better from 99.3 to 99.9 or better. So again, we're in San Francisco, low prevalence, but if you have the Abbott or the Roche test or one of these great tests like this, you can still rely pretty darn heavily on the positive result being correct. And again, negative is 100%. So there are situations, even in San Francisco, where a positive result can be really highly reliable. Now, I want to give one more example, which is someone in San Francisco, so again, low prevalence, but somebody who had classic symptoms. So again, we don't think that everybody who had symptoms had coronavirus, but it's definitely higher than 1%. So I'm going to guess, say 5%. 1 in 20 people who says, yep, I had a bad cough and I had horrible fevers and I was in bed for a week. I never got a PCR test and I want to know if I have antibodies. They get this test, and if we believe that like 1 in 5 of those people, going back now to the lower specificity, because we know that if we have the higher specificity, it doesn't make a huge difference. We're pretty much reliable. But remember, with the diasorin test, we were saying that a baseline sort of random screening would give you a positive predictive value of almost 60%. So not awesome. But if you think about somebody who's having symptoms, now the positive predictive value goes up almost 20 points to 78.3%. And again, our negative is 100. So again, knowing that there's an almost 80%, 78.3% chance that if I have antibodies and I had those symptoms before, I did have it and I do have antibodies, that may be valuable. Some people may be making decisions. And, we get these calls from people about, I have a sick relative, or, I need to go care for an older relative, and I'm not sure if there's any information that would help me make this decision. I had some symptoms, I didn't have symptoms. So you can, armed with this information, you can help patients interpret that information. They want us to give them absolute answers, and we can't. I mean, there's just uncertainty, as we all know. But I also think that giving them no insight and saying like, look, we don't know anything. We don't know if the tests are good. We don't know if the antibodies are protective. That kind of leaves them without the kind of guidance that they're looking for from us. And I think with this kind of information, we can give them a more nuanced answer. We can say, look, there's a decent chance that your positive result is actually accurate. So I think it's very possible that you have antibodies. And we don't know yet if antibodies do provide immunity or protection. We don't know if they do for how long, but a lot of experts think that they do because we're seeing that convalescent serum may be helpful. We haven't seen a lot of people who have recovered getting reinfected. So we don't have the definitive proof, but there are signs pointing in that direction. And again, that might help somebody make a decision that they have to make. That's a hard decision. So here are my takeaways. So how reliable is the test result? The tests that we send to LabCorp and Quest have a very good sensitivity and specificity. We're not talking about the in-office tests. We will have good ones of those as well, but the tests that we're sending off now are good tests. A negative test is a negative test, no question. And then a positive test, you have to kind of think a little further about what's the prevalence, which test am I getting, and again, I think even the diasorin might get phased out. We'll just be seeing the Abbott and the Roche and the 99.9 specificity test. But in most cases, we're still talking about pretty good positive predictive values in the 75 to 95% range. So again, you can talk about that with your patients, and you don't have to quote even exact numbers, but you can tell them, there's a good 3 or 4 in 5 chance or better that your test is accurate. And then you can help them make that decision. So this is what I was alluding to earlier, this question about what about visiting my blank, my older vulnerable relative or immunocompromised relative or friend, et cetera. Again, negative tests provide certainty. We can say that a negative test means you have not mounted an immune response, you don't have antibodies. Positive tests can provide useful information, but we can't give them certainty for multiple reasons. Primarily, the test may or may not be always positive. Although when you get in a higher prevalence place or you have the higher sensitivity and specificity tests, we can be pretty confident that a positive test is accurate. And then also, we still don't know for sure that these antibody tests do signal protection and immunity. As I said, I think we're starting to see evidence pointing in that direction. I've heard multiple, literally world experts in virology and immunology saying basically, yeah, they think that we do have immunity once we've recovered. That immunity may last a year or two. Similar to other coronaviruses, it will probably go away. So again, if we're looking for certainty, we can't, but we can partner with the patient. We can tell them what we know, what we don't know, and help them think through some of these challenging decisions that they're facing. So let's talk about the last question real fast. When should I order both a PCR and antibody test? You probably saw the announcement that we're starting to roll this out across all our offices. I can tell you, I don't know, but here are my thoughts. Certainly, we're going to see return to work requirements where employers are going to ask for both. Hey, we'll do it. Patients may just want to know. And again, I think with the right understanding, the right information, it's great. They want to know. Great. They want to get both tests. Maybe that's fine. There may be times where you should counsel them that they don't need a test. Like for example, if their symptoms were 8 weeks ago and they're feeling totally better, they shouldn't get a PCR. There's no question. Or if they're been sick for 3 days, they shouldn't get an antibody test. I mean, those are clear situations. But there's probably a window, especially in the 3 to 4 week post-symptom onset, where it might make sense to actually get both tests. And the reason I say that is because you guys have probably seen this already. This was recently published, nice, colorful, really nice graphic. And I think the data are pretty good behind this, that you can see kind of around week 3, week 4, the PCR positive likelihood starts to go down, the antibody detection starts to go up. And so in that period, you might get a negative PCR and a positive antibody, or a positive PCR and a negative antibody, and having both tests might be helpful to let somebody know, hey, do I have coronavirus? Did I have coronavirus? So there may be situations where getting both makes sense clinically. And we're going to learn more as the tests get better and better, as these kinds of curves become clearer and clearer, as we start to understand, do everybody make antibodies? Do people who have asymptomatic infections make the same kind of antibodies as people who have more severe infections, et cetera? So that's it for me. I really appreciate you sticking with us to the end. As I said, I think understanding kind of what goes on underneath the hood with a lot of the tests that we do, the sensitivity, specificity, and prevalence, how those give us our test reliability, is really helpful. It will serve you in lots of different situations when coronavirus is sort of moved away from the forefront. And I also wanted to say, if you have any questions about this stuff, please reach out to me. I don't have all the answers, but it's really great to dialogue. It's great to hear other perspectives. And I think we all get better when we can learn from each other. So please keep the dialogues coming. I love what I'm seeing in the Slack rooms, et cetera. And I hope that you guys are all doing well and have a great weekend.